Okay, so we're doing a sample problem. This is in topic 2-1. So we're talking about slope-intercept form, finding the rate of change, which we also call the slope. So if you'll notice, my problem is find the rate of change between 2 points. So they didn't give us a graph in this particular example. They just gave us the 2 points. So there's a formula we could just plug in and find out the rate of change or the slope, but I want to walk you through kind of the logic behind it or the intuitive process behind it. So again, they did not give us a graph, but if we wanted to, we could go ahead and create the graph, and we could just come up with the graph using graph paper, or as you'll see, you really don't have to have a specific perfect graph to still kind of figure out exactly what you're supposed to be doing. My dog is about to knock my camera over, so hopefully he will not. Stay. Stop it. Lay down. So anyway, if I have these 2 points, I could just really quickly kind of make a graph. So that would be my y-axis. That would be my x-axis. And again, it doesn't have to be perfect. I'm not even super worried about every single coordinate point that was on here. So this is 0, 0. You need to know that. That's the origin. That's 0, 0. From there, I'm just going to kind of fill in where these different points would be. So for example, if I said -5, -3, that means my x value is -5. My y value is -3. So -5, let's say, would be somewhere out here. Again, I'm just picking where -5 would be. That would mean 4, 3, 2, 1 would be somewhere in there. So -5 would be also, or I'm sorry, +5 would be approximately right there, which means +5 would be approximately down here. I'm sorry, -5 would be down there, and then +5 would be somewhere up here. That's plenty of information for me to be able to just kind of get a visual picture of where these different coordinate points are going to be. So -5, -3, clearly -5 would be right here for my x value, and then I need to go down to my -3 value. So -3 and then down to probably about here would be -3. So that would be 1 point, because if -5 is all the way down there, -3 would be somewhere in there. So that's one of my points. That's -5, -3. Hopefully you can see small print on your screen or whatever you're looking at. Well, now I just need to figure out where would my other point be approximately. Well, if -5 is here, that would mean -1 would probably be somewhere about there. Just taking a quick rough guess. And if +5 is here, that would mean +4 would be roughly about here. So this point would be somewhere maybe right around here. All right? So I've just really kind of given a good estimate of where these 2 different points would be. I would connect these. I do have a ruler, which I'll use real quick. It's probably going to smudge my graph and my stuff, but I'll do my best to keep it from messing everything up. Just kind of roughly go through these. So there, that's not too bad. And again, it would keep going on in both directions. And that would keep going, and that would keep going. Oh, I should have done that line in red. Just imagine that line is in red, since I didn't do it in red. So anyway, I have my x and y axis. I've graphed the line based on the 2 points that they gave me. And now I can already tell immediately a couple of things about this line. The first thing you need to know, or you should be able to tell, we've gone over this, that line is going up if I'm moving left to right. So I would think about walking upstairs if I were traveling up that line or traveling on that line. Well, I know if I'm going up the stairs, that means my slope or my rate of change should come out positive. I can tell already by the shape of the line I should have a positive rate of change. So that's one thing that I've already kind of figured out just by graphing it, even though it wasn't a perfect graph. Now I need to figure out, all right, well, I need to figure out rate of change, and I know that the rate of change which, yes, is also called slope, but I'm going to keep referring to it as rate of change because you'll hear that in algebra as opposed to slope. So my rate of change is equal to the rise over the run, which if I just come in here, I can kind of get a pretty good idea of what the rise and the run are. I'm going to use some different colors. So my rise is going to be my vertical distance. So if I'm thinking about going from this point to that point, my vertical distance would be from here straight up to about here. So I could just kind of dot in what my vertical distance is, saying, okay, well, I'm going all the way up to there for my rise number. It's not perfectly straight, that's for sure, but good enough. So that green distance, the distance from here to here before I cut over, that's going to be my vertical number. And I can just count units. If I'm on -3, I would go from -3, I would go 1, 2, 3 to get to this point, to the x-axis. And then if I need to go all the way up to 4, I would count 1, 2, 3, 4. So I'd go 3, 4, 5, 6, 7. So from there to there would be 7 units. So my rise would be 7. Well, now I need to look and try to figure out my horizontal distance. So my horizontal distance is going to be from that line to that line. Hopefully you can see the blue. So I just kind of dotted it in. I know my horizontal distance is going to be from this spot right here on my x-axis to this spot. So from -5 to -1. Well, again, I just kind of count the units, but it would be -5 to -4 would be 1, -3 would be 2, -2 would be 3, -4 would be 4. So let me go over that again. A lot of people are looking at the numbers on the axis, and they're saying, okay, well, I know this number has to be 4. I'm going to go ahead and write these all in, I guess. 3, 2, 1. So that'd be 4, 3, 1, 2, 3, 4. 1, 2, 3, 4. Okay, so now I have them in there. A lot of people are just looking at the number on the axis and saying, okay, well, my distance has got to be 4 because I'm going to 4. It has nothing to do with where this line is on the x and y axis. It has to do with the angle or the steepness of the line. This line could be moved all the way down or all the way left or all the way over. It's still going to have the same rate of change. I'm measuring the distance from this point to that point from my rise, and the distance from this point to that point for my run, which is the same as the distance from here to here for my run, and same as the distance from -3 up to 4 for my rise. So visually, I can just say, okay, well, I know if I'm going from here to here, that number was 7, and if I'm going from here to here, that number is 4. So my bottom number, going from this point to that point, which is the same as from -5 to -1, my bottom number is 4, and that is my rate of change, 7/4. All right, so hopefully you followed that. I know it's a little difficult to follow sometimes when I'm not in front of you. Here's the end result, though. If you'll notice, the distance for our vertical number, our rise, it's simply, all we're doing is we're taking the distance between the y coordinate we have here and then the y coordinate we have up here. This point was -1, 4. This point right here was -1, 4. Well, all we did is we counted from -3 up to where 4 is. So we really just took the distance between the two. Well, or you could even say the difference between the two numbers. So all we really did is we just said, okay, well, I need to go ahead and I need to say, what is the distance between 4 and -3? Which if I did it a different way, I would say, what is the distance between my y value in one of them. So 4 is my y value in one of them. I'm going to call it y2, subtract y1. And then for my run, I'm just taking the difference between the two x values. -5 subtract -1 would give me my run. Technically, it'd actually be -1 subtract -5. So I'm also going to do y2, x2. It would be x2 subtract x1. So what I'm going to come back up and do, I didn't do this initially, we're going to label this my first point over here. We'll label this my first point, just so I can tell the difference between which x and which y I'm talking about. This is my first point, and this is my second point. Those twos don't mean anything. They're not math. It's just a different way of labeling the x and the y, so I know which one I'm talking about. I'm just calling this the first point and this the second point. So this is my x from the first point and my y from the first point. This is my x from the second point and my y from the second point. So now that I have this formula, I could actually just plug in the numbers, and I can say, okay, well, my y2 value is this 4 right here. So I plug in that. My y1 value, and then I say subtract. My y1 value is -3. And then that's all going to be divided by my x2 value. I just find my x2 value, so that's -1. And then that's going to be subtract my x1 value, which is just -5. And now I have an actual formula I can use if you like the whole step-by-step process better. So if I do the math, 4 subtract -3 just becomes 4 plus 3. 1 subtract -5 becomes -1 plus 5. And I wind up getting 7 over 4, just like I did in the first example, or in the first way to solve out the problem. And if you'll notice, I had already said at the beginning, my slope should be, my rate of change should be positive because I know the line is going up. And when I did the math, sure enough, the slope came out positive. The rate of change came out positive. Even if I would have reversed this and made this my first point and this my second point, I would have still gotten a positive number. I'll do that in class. I'm not going to do it on the video. But hopefully this will help you review after the lesson.